Hello guys, welcome to this session. So in this session we're going to be talking about IP version 6. We talked about IP version 4 in two separate videos. So if you haven't watched that, I'll make sure to link the video links to the IP version 4 videos on the description section. So let's talk about IP version 6, and this is basically different protocol from IP version 4, and it basically helps us to create nodes, identify those nodes, and enable communication in between networks, only that it has a different working system from IP version 4. So if into this kind of content, remember to hit the like button, comment on the comment section below, and also subscribe to my channel so that you're updated each time I upload a new video. So let's get into IP version 6. So in order to learn IP version 6, you have to forget IP version 4. Don't entirely forget them, but you assume that you don't have IP version 4. And as we said earlier, IP version 6 is a completely new way to identify nodes, create networks, and enable communication between devices. And as we all know, computers understands ones and zeros, so that is what we are going to use. And these ones and zeros are in memory. So the question we need to ask ourselves is, how many bits in memory do we need to enable IP version 6 communication? For IP version 4, we took 2 to the raised to the power of 32, and that came to approximately 4.3 billion IP addresses. It was not enough, so we had to scale further, and we went for 2 raised to the power of 128. That gave us 16 bytes in 8 groups of 2 bits. Okay, and that is basically enough for us to create an entire new protocol that will help us to create nodes, enable communication between devices. But in IP version 6, we don't use binary like we used in IP version 4. That is why I was telling you need to forget some of IP version 4 concepts. Instead, we use hex digits. There are different numbering systems or number systems that exist out there. There is a ASCII, there is a hex digits, there is binary, there is decimal. So in IP version 6, we are going to use a hex digits because representing 2 raised to the power of 128 in terms of bits, that could be a bit long, and it could be a bit complicated when it comes to us humans. So we're going to get 8 blocks of 4 hex digits. That is as I have illustrated here below. And when you're using hex digits, you can even assign names to your IP addresses. For example, you could have food, cafe, you could have feed, and the rest of the IP version 6 address. So when you're talking about an IP version 6 address, it's basically what you can see on my screen here, the food, cafe, feed, the 001. And let's get to understand now how we can communicate, since we have solved the problem of allocating certain bits in memory to help us create this new protocol. So if you can look at the IP version 6 address, it's very long, and it can be very cumbersome to remember some of these digits, hex digits. Since they are very long, you have 8 blocks of 4 hex digits, so that could be quite cumbersome to remember. So what we do is that if you have zeros that follow each other consecutively, you need to remove the extra zeros. You can represent them with just 1 0, but then it would be also long to just put zeros with the colons, and they are not necessarily representing what we would call as a significant hex digits. So we need to shorten this further. So what we basically do is that for the zeros in different blocks, that are consecutive, instead of using the zeros, we are going to use a double colon for zeros that are leading zeros, or zeros that are occurring concurrently in different hex blocks and do not have any other significant hex digits in between. So you basically use a double colon instead of the zeros, and that would come to the food cafe fade double colon 1 if we were working with the example that I have on my screen here. So you need to simplify that so that it's even easy to remember. Now there are certain things that you need to keep in mind. If you need to use the double colon, you only use it once. Say for example you have a ff 0 0 1 0 0 0 1. Those are the zeros occurring in different blocks that are consecutive. Yes, they are consecutive, but they are happening in between blocks that have significant hex digits. So you basically choose where you're going to use the double colon, and you're only going to use it once. And I have indicated some of the correct ways to represent IPv6 addresses using double colons, and you can go through them here. Remember that if you use a double colon twice, that IP address is going to be ambiguous. It's not good. No one is going to understand how many zeros were there before the double colon. So you need to use the double colon only once. Now let us solve the problem of communication. Since we have already allocated data, we have already seen how you allocate these specific IPv6 addresses and how you can shorten them. So in communication in IPv6, we have three scenarios. There's one where you have streaming data. For example, if you're watching this video, you'll be watching it on YouTube, and this is streaming data. So if you lost a packet or two, it will not make a significant difference in the quality of content that you're delivering. Say for example in a phone call, there's just a stutter somewhere, you will not feel that much of a difference. And in these cases we use UDP, that is user datagram protocol, for version 6, for IPv6, that is UDP version 6. Now you have another scenario where you need all your packets to be delivered, and you need to confirm that you have received all your packets. Remember, UDP is a stateless protocol, meaning that it does not check for arrival of packets. That is why we were saying if you lose a packet or two, it will not make such a difference. But if it is not necessarily streaming data, and you need to make sure that you have received all the packets that you sent from one end to the other, you are going to use what we call as the TCP version 6, that is a transmission control protocol for IPv6. Okay, and this is stateful, meaning that it's going to remember to ensure that packets that were sent were delivered, and it's going to check on that, unlike in UDP. So there's another scenario where we need to control the IPv6 world. If machines have errors, if you need to collect information on certain machines, if you need to run diagnostics on the certain machines or devices, we use what we call as the ICMP version 6, that is the Internet Control Messaging Protocol version 6, and this controls devices in IPv6 world. So whenever there is an error in a device in a network, it uses the ICMP version 6 to communicate and say that I'm currently down, so you need to allocate another server or another device to that specific task, or whatever diagnostics you're going to assign to that field device. So those are the three scenarios where we have streaming data, where we need to check arrival of packets from one end to the other, and managing the IPv6 devices wholesomely, or the IPv6 world wholesomely. So those are the three scenarios. Let us see. let us see how we can assign IP addresses to specific devices in our network. So in case a computer does not have a DHCP server located to it, it's going to assign itself an IP address, and in IP version 6 we call this a SLAC, or a stateless address auto configuration. And this is where a node or a computer generates an IP version 6 address for itself, and normally it's going to be in the range of FE80, then the corresponding values. But in SLAC, the IP address range will be FE80. So that is the first hex block. Okay, let us look at scope. And when I'm talking about scope, I'm talking about the how wide your network is. So in IP version 6 we talk of scope, and you have what you call as global scope that covers the whole internet. It refers to the whole internet. A unique local scope, this is everything in a local area network that is behind a router. You could have several routers in your network, but this specific unique local address will be to that specific router that goes out to the internet. Okay, we have what we call as a link local scope, and the link local scope refers to devices behind one switch, and they can never be routed. It will never be a routable address. So since we are talking about addresses here, and it is only valued on one collision domain, that is on the same switch. We talked about collision domains in the IP version 4 videos. So if you haven't heard or you haven't looked at the IP version 4 videos, kindly go and have a look. I'll have the links in the description below. So let us come to the least part of our network, that is a machine or a host, and that we are going to refer to as a local host. Okay, the different scopes have different IP address ranges, IP version 6 address ranges, and we are going to start with the loopback address. For IP version 4 we talked about 127.0.0.1. In IP version 6 it's a :1 with a prefix of 128. That is the loopback address for each machine in a network. There is what we call as the unspecified address range, and that is a :, with a prefix of 128, meaning that you are assuming that :, represents all zeros, leading zeros. We talked about leading zeros in the beginning of the video. Okay, the global unicast or the global unicast scope, the range, the IP address range will be 2000 and 2000 :, with a prefix of 3, meaning that when you put a prefix, the number behind the prefix or the number behind the slash says that specific those specific bits are very significant and they represent a certain scope. So in the global scope, the IP address range will be from 2000 : with a prefix of 3. We have what we call as the unique local address. That is the unique local address. It ranges from FC00 : 7, and this specifies a specific local area network. Okay, a specific local area network. And remember, you could have different LANs in your network, but this represents a unique local area network. Okay, this is what we call as the link local unicast address, and these are devices behind the same switch, and the IP address range is from FE80 : 10, meaning that you are going to use 10 bits to represent the link local unicast address. Now note that hosts in IP version 6 can have multiple IP version 6 addresses. That is the local host address, it will have the link local address, and depending on the ISP or the internet service provider, you could have 2, 3 or 4 global unicast addresses. That is just in case you change the scope. The multiple IP addresses are there so that in case you change the scope, you're moving from a unique local to global unicast, so you need to change the IP address, and basically the host will have multiple IP addresses for such kind of scenarios. Now, for hosts in our network, you need to remember that always use the smallest scope possible. The IP address range for IP version 6 is so large such that it can be confusing at times, so you need to use the smallest scope possible when you're addressing your or giving addresses to your specific hosts in a network. Now let us look at how we can subnet IP version 6. How can we scale? How can we get more networks from one IP version 6 address? Okay, how can we get more networks? So we are going to work with this example that I had provided before. That is food, cafe, fed. Then we have all other zeros except in the last text block where you have 1. So in order to subnet, you divide the IP version 6 address into 2. That is the network part and the host part. Now in the network part, 48 bits are given to the internet service providers. All internet service providers, these 48 bits can cover all of them. I am sure they're even fewer than what the number of bits that have been provided here. It can accommodate a lot of ISPs. So the first 48 bits are for the ISP. Then the next 16 bits is what you use to subnet. And remember, we're using hex digits here. So if you need to subnet, you're just going to increment the value from 1, 2, 3, 4, and use the hex digits to increment so that you can get your specific subnet. The rest of the part is just the host part, and basically whatever you do is that you're going to increment from the last hex block the same way that you have been doing with the subnet part of the IP version 6 address. So that is the basic structure of the IP version 6 address and how we can scale to get different networks from one IP version 6 address. Now when you're in a command line, you need to gather the information about IP version 6, instead of using the IP address, IP add grep, that is in the command line. This is the command that you need to enter: IP add grep inet6, and it's going to basically show the IP version 6 information of that specific address or that specific host. If you are looking for IP version 4 information, then you are going to just put a 4 where you have inet6, you just put inet4. But in IP version 6, you're going to use inet6. When you need to check for reachability of a service or a website or a machine or a server in your network, and it is using IP version 6, in the ping command you just add a -6, and then you specify the server you want to look for the reachability of. It could be www.ibm.com, it could be www.google.com, anything generally, but the 6 will make the difference, showing that it's showing a IP version 6 information. Now say you're using the web browser and you need to enter an IPv6 address. Say you're using a browser and you need to reach to an IPv6 address or an IPv6 server. What you're basically going to do is that you're going to include the IPv6 in square brackets, and then later on you can specify the port number as I have shown on my screen here. So that is how you check for IPv6 information, reachability of an IPv6 address, and how you can access a server using port numbers through the web browser in IPv6. Now remember that most people are still using IPv4, and migration is still happening. There are different ways to integrate IPv6 in your systems. You could have what you call as a dual stack, and this is where you basically accommodate IPv4 and IPv6 addresses in your network, such that you can use either IPv4 or IPv6. So that is one migration technique. You could have what you call as a tunneling. This is where you use a VPN or a third party, and this basically helps you to translate your IPv4 addresses, or what you call as a IPv6 addresses. It's going to convert them to IPv6. It's going to convert IPv4 addresses into IPv6 addresses. And Hurricane Electric is one of the third parties that you could use, or one of the VPN providers out there. This is what we call as a NAT64, and this is basically a protocol that helps us to translate IPv6 to IPv4 addresses. Remember, in IPv4 we are talking about public and private IP addresses. It's the same concept in NAT64, where you translate IPv6 addresses to IPv4 addresses. I believe I've covered much on IPv6. We have yet to cover on the type of packets that exist in IPv6. So join me in the next video as we discuss the type of packets that we can have in IPv6, and we are also going to get into detail of DHCP version 6. So thank you for joining me in this session. Thank you for sticking to the end. If you're into this kind of content, remember to hit the like button, subscribe to my channel, and also comment on your views about the videos, or any other topics that you'd like me to discuss, or your views on this specific video. So thank you for joining me, and see you in the next video.